This is an experiment to determine the magnetic field of a permanent magnet that looks like this. The red side of the magnet is the north, the south is the white, and the magnetic field goes across the gap. Now the relationship that we're going to be using in our analysis is the force on a current carrying wire in a magnetic field. F equals I L cross B. So the current is going to be flowing through the little metal strip on these plastic inserts. And so the current goes this way across the front of these inserts. And the way that we're going to immerse it in the field is to simply lower it down and have it running right lengthwise through the gap. Remember, it's a cross product, so when you take the direction of the current along that length, which is away from me, and cross it with the magnetic field, you'll get a force, and that force is either going to be up or down. And the way we measure the force is by putting this magnet on the scale, and when we turn on the current, so we turn off, we turn on the current, there will be a force on the magnet. Now the force on the current is a Newton's third law action-reaction force, where one's on the current, one's on the magnet, and it is the force on the magnet that we're actually measuring because that's what the scale is going to read. So the data that you will be taking will be the change in mass of the magnet, so that'll give you the force, and the current. You'll have a meter over here where you can read the current. And then you'll do one set of experiments where you leave the length of the current segment constant, and you change the value of the current, and you'll get a graph where you'll get the magnetic field. And then what you'll do is leave the current constant, and you'll change the length of the conductor by putting in different inserts. And you'll do a second graph whose slope will also be magnetic field. And from those two slopes, you will be able to determine the magnetic field of the little bar magnet.